Okay, so let's start with current. It's denoted with I, and Q is charge. And T is time. So the current is the rate of change of charge. Okay, and then we'll have this whole course about circuits. Okay, so to build a circuit, well, you need some source which will power it. One example is the voltage source. So battery is an example of a voltage source. You need wires, and then that goes to some load. Okay, examples of a load would be a resistor. A bulb. Okay, now what's happening here is that the voltage source is needed because it powers the load. The current flows from the voltage source to the load, and the direction of the current is always from the positive terminal to the negative terminal. So the positive is shown and the negative is not shown, but it's the other one. So the current flows this way, but the charge flows the other way. So that's the electrons. Okay, and why would charge flow that way? Charge is negative, so it's a negative, and so it will be repelled by the negative terminal and flow to the positive side. So many people think of the current as flow of the positive positrons, the positive part of charge, right? Or a current is positive charge. This is not the only way you can draw a circuit. There are some other ways. Yeah, that's the ground. So don't get scared if you see a ground like that, just showing that there's a common ground. Another way people will draw this is they won't really show a closed loop. So there's no closed loop. It looks like it's an open loop, and current cannot flow in open loop, but it's actually closed because it really doesn't matter where the ground is. The ground is connected to each other. So both these are ground terminals. Okay, so all these three are the same. 1, 2, 3. So 1, 2, 3 are all equivalent. The same thing, drawn differently. Okay. Questions? Okay, so let's start with the simplest thing, which is needed on almost every circuit. We'll start with the resistor. Basic electric elements. Here's the first one is the resistor. Okay. A resistor is something which you can buy. Do you know how much a resistor costs? Any guesses? It's expensive. I think you'll get 10 of them for 25 cents. It's very cheap. So a resistor would be, it looks like a piece of wire, but there's like an element which has colors, and there'll be like, let's see, what? The 3 bands. We will put some random bands. And then on the other end, there will be a single band. And that yellow is supposed to be gold. Okay, so these are bands, and say that this is the length, this is the cross-section area, and then the rho is the, it's called resistivity. Okay, so R is the resistance. What do you mean by resistance? Resistance is something which resists the flow of current. So bigger the resistance, bigger will be the opposition to current. Think of resistance as mass. The bigger the mass, the harder you will have, the difficult it will be to push something from rest, right? So the bigger the resistance, the harder it is to send current through it. The resistance is given by rho L divided by A, where A is the cross-section area. L is the length, and then rho is the resistivity. Okay. So the longer the length, the bigger, the higher the resistance. The larger the cross-section area, the lower the resistance. This is kind of important. When people normally have bigger wires, thicker wires are good because they have low resistance. In general, low resistance is good because, as you'll see, the bigger the resistance, there's voltage drop across a wire. So when you have people having long wires, you'll see that the net voltage coming to a particular device is going to be less because there's a voltage drop across that wire. So you want to have short wires, but thick wires to reduce the resistance. So what are these bands about? Well, these bands signify the resistance of the resistor. It's basically color code. So let's call this bands as, okay, so clearly there's going to be 3 bands on one side and a single band on the other side. That's how you know how to club them. Let's say that these are A, B, C, and D. That is these bands. If you want to read the resistance from these bands, then it's simply R equals A B times 10 raised to C plus or minus the tolerance due to. Okay, so I'll give you an example of what this means. So each of these colors signify a particular value, and those values are, so start with 0, 1, 2, 3, 4, 5, 6, 7. Okay, so black. So if you see black, that number is, it's going to be 0. That if it's on A or B, that B will be 0 or A will be 0, depending on what it is. Black, brown, red, orange, yellow, green, blue, violet, gray, and then white. And then tolerance band, this is the number D is, it can be only 3 things: gold, silver, or there's nothing. Okay, there'll be 3 bands, no 4th band. If it's gold, that means that the tolerance is plus or minus 5%, silver is plus or minus 10%, and nothing is plus or minus 20%. The bigger the tolerance, the bad, the larger the tolerance, the bad it is, because then it makes the resistor less precise, right? So it means that the resistance is going to be plus or minus that. So let's see, if you have, So if you have green, brown, and then red, followed by, say, yellow. So what you'll do is you'll read the number from this table. So green is 5. Brown is 1. Red is 2. And golden means it's plus or minus 5%. So this value would be 51 times 10 raised to 2 plus or minus 5%, which means it is 5,100 plus or minus 5%. Okay. And so that's how you'll read. Now, this is one way of doing it. The other way to do this is, how will you find the resistance of a resistor? Where's taken 411? How will you do it? Multimeter has a knob, so you will use a multimeter in lab 3, I think. Yeah, lab 2. Sorry. Multimeter is a device where you can read the voltage or the current. All you need to do is turn it to the resistor knob, connect it to the resistor to 2 wires which stick out from this. I'll just tell you the resistance. It's probably more faster, more accurate than this way. Okay, so there are ways to remember this. If you go to Wikipedia, you can find mnemonics to remember this. But really, if you have nobody really remembers this. You just go and either use a multimeter or just look at a sheet which gives you the values for different colors, and you can read the resistance. In circuits, we need to represent resistors using some symbols. So the symbol used is, it looks like that of a spring. That's the symbol for resistance. Okay, so you see that, you need to interpret that's the resistor. Just like when we draw models in mechanical engineering, we have mass spring, spring mass damper. Similarly, there are circuits which symbols, and that's the symbol for circuits for resistance. Now, there are other resistors which I think are very interesting. Potentiometer is one of them. Okay, a potentiometer is a variable resistor. What that means is that you can set the resistance of a potentiometer. This is basically a system with a knob, and if you turn the knob, it changes the resistance of the potentiometer. So if you don't know what resistance you need to use in a circuit, you put in a potentiometer, and then you can switch the resistance. It's used in things like if you know encoders, which measure the angles. You put a resistor. Basically, when the arm moves, the angle changes. It changes the resistance because it's connected to a potentiometer, and that resistance can be read, which then gives you the angle turn. That's one way of using it. Another device is called a trim pot, which is also a variable resistor. However, it's used in a device where you require some calibration. So you put a device, and let's say that you need to set something, the resistance of that device when you install it. And so they'll provide you with a trim pot. So you just use that knob to change the resistance. And once it's calibrated, you just not disturb it. But it's, for all purposes, basically a variable resistor. The symbol for a potentiometer is something like this. So you draw a spring, which is a resistor, and then draw an arrow which shows that it's variable. Another way people draw it is this way. So this is just showing a slider, and changing the location of the slider changes the resistance, or they simply put it as this. Okay, all these are valid symbols for potentiometer. I forgot to say the units of resistance. Okay, it's ohm. Symbol is omega, and then and then you will see that you will have a resistor as 50, which means it's 50 ohm. Okay, so next, this is all about resistors, and we'll use resistors in one of the labs. And you'll see it'll be used in other circuits too. Let's go to the next part, capacitors. Okay, a capacitor is basically two metal plates. Okay, which are then connected to wires. But then they have what is known as a dielectric material, insulator. So insulator doesn't conduct electricity. It's called dielectric material. Okay, so what happens is when this is the wire. So when you connect this capacitor to a circuit, what will happen is, let's say you connect to a circuit, what will happen is that the insulator will prevent electricity from flowing, unlike a resistor which allows current to flow, and all the charge will settle. So all the negative charge for here, for this instance, will settle in over here. Negative. So all the negative charge settles there, and if you touch it, you might get electrocuted because then that charge will flow through you. So you don't really want to touch a fully charged capacitors. You can find capacitors in almost all devices. By that I mean you don't see them physically; they'll be inside. So, for example, we had a microwave, for example, would have a capacitor inside, and then there'll be instruction says, don't touch this. I mean, it's very important because if you touch it, then it's just going to electrocute yourself. Okay, so how do you, so just like we have, something. Yeah, I forgot to write this. So the voltage is in a resistor going back. Voltage is R times I. So this is the voltage. This is the current. So this is basically the what they call the constitutive equation for resistor. That is, if you pass a voltage or you connect a battery, and given the resistance, it will tell you how much current will flow through it. So the bigger the R, the lower the I. Okay. For the capacitor, the relation is Q equals CV, where Q is the charge, V is the voltage, and C is the capacitance. Okay. The units for capacitance, I'll come to that, it's farad. So note that there is no current appearing in the capacitor, right? Because a capacitor does not allow electrons to flow. What happens, the electrons are stuck on the capacitor, and when you, for example, go and touch it accidentally, that charge will flow into you, and that will become current, and it will probably hurt you. So the units of capacitance are farad. So Faraday was a scientist. They are usually not. So remember that the bigger the capacitance, the bigger is the ability to store charge because Q is proportional to C. So the capacitance are usually in in picofarad. Picofarad, so it's called pico. So pico is -12. Or they come in microfarad, mu. That would be 10 raised to -6. Okay, and you will not see like farad. I mean, if it's in farad, then it's probably going to store a lot of charge. So how do you read the capacitance of a capacitor? When you buy a capacitor, they actually, some of them look like this. Capacitor. Okay, you can connect any of this terminal to positive or negative. It doesn't really have a polarity. You'll see that capacitors have three values written on them. So just like bands on resistor, there are three numbers in that, and those three numbers gives you the capacitance. So for example, if the numbers are 1, 0, 2, that means that the capacitance is 10, the first two digits, times 10 raised to 2. So this would be the third digit appears. So this is going to be that picofarad. Okay, they are not sold as well. You won't really see a farad unless it's some really big electronic item. So 10 times 10 raised to 2 picofarad would be the value. So the default is picofarad. Okay, now sometimes you see that a capacitor doesn't have three numbers, it only has two numbers. If it has two numbers, then you should assume that the third number is 0. Only. So in this case, assume third number is 0. For example, if you have 22, you'll interpret this as 220, which would be 22 times 10 raised to 0, which is 22 picofarad. Okay, so symbol. You either see two lines. So those two lines, the horizontal lines denote the capacitance, and then the other ones are the wires. Or you will see something like this. Okay. Just gives you a sense that there's some polarity in that one end has to be connected with a positive, but there's nothing like that. A capacitor does not have polarity like a light emitting diode. Okay, we'll do one last thing and we'll stop the inductor and voltage and current source. So an inductor is a device which stores energy. How it stores is this is how what it looks like. It's basically like a donut, but then there's a wire which wraps around it. That's a magnetic core. And this is wire. Okay, so the constitutive equation for an inductor is V equals L di dt. Okay, where V is the voltage, of course, I is the current. And L is the inductance. Okay. Inductance units are Henry. Okay, so the convention is, and I did a mistake for ohm, you should always write the units with a capital letter H, but then when you write it as Henry, you should always put, it shouldn't be caps, H should be lowercase. It should be lowercase. Same for farad, same for ohms, because it's not a proper name, it's basically the unit. But when you write it as H, H should be capital. Okay, so note that if the current is zero, that is, a steady state current is passing, then the voltage across the inductor is zero. It's only for it stores current charge only when the current is pulsating. That is, I is not constant, I is varying. So if I is steady, then voltage across the inductor would be zero. So note, if I is zero, then di dt is zero, which means that the voltage is zero, which means it cannot store charge. It only stores charge when the voltage is, the current is pulsating. Okay, the symbol for an inductor is something like this. I would say it looks like a torsional spring. Okay, and the values for inductor are printed on the inductor, so you don't have to really scratch your head and figure out what it is by like the colors in the resistor. It's just written off, and they'll be in Henry. Okay, so two more things when we're done. I want to show a voltage source, which we've seen. A voltage source would have, which will provide voltage. An example would be a battery. And a current source will be denoted this way. Okay, if the voltage is infinite, then you have the current can be. If the voltage is infinite, then you can basically have a current source. You can get a good current source by using a power supply which has a voltage and a current knob by setting up the voltage to be infinite or maximum, and then you can just limit the current to whatever you want. That will be your current source. And vice versa for voltage source, which is you'll take for the voltage source, you'll move the current to infinite or maximum possible, and you'll keep the voltage to whatever you want. That will be a voltage source. Okay, I'll stop and we'll meet on Thursday.